Chapter 6. We're going to start by talking about a probability distribution, but I don't have a lot to tell you about them because you've actually seen probability distributions before. We just didn't call them probability distributions. A probability distribution ties together two things. Relative frequency distributions from Chapter 3, if I remember correctly, maybe it was 2, and the fact that we can use relative frequency to calculate empirical probabilities. So if you put those two concepts into one and make a table with all the empirical probabilities, you've just created a relative frequency distribution that just so happens to consist of probabilities. So we call it a probability distribution. Just like for a relative frequency distribution, the probabilities will add up to 1, or close to 1 if they were rounded off. The events are disjoint. That will always happen. And this is an example of why what Christiana was asking me is such a good question. I get the question about what does disjoint and dependent have to do with what do those things have to do with each other? I get that every single semester. So I'm going to keep reminding you of the fact that they don't have anything to do with each other. They don't mean the same thing, because that is a common point of confusion. If we already know what a probability distribution is, why even bother talking about it besides just giving it a new name? Well, it helps us figure out some useful real-life stuff. This one in particular, called expected value, is really useful in real life. It tells you what to expect. Businesses will pay a lot of money if you can tell them what to expect so that they can profit from that. They can plan ahead and make a lot of money off of knowing what to expect or what will happen. And that's just a single example. So I'm going to show you what this formula means and how we use it in a probability distribution. You've actually seen this symbol before, right? This means mean, which might confuse you at first, because why am I calling it expected value then? Because I told you back in Chapter 3 that that was called a mean. It turns out that expected value is the mean of a probability distribution. But a probability distribution, which I'm going to abbreviate like this because I get tired of writing that long phrase, a probability distribution is just a relative frequency distribution, and we calculated means for those back in Chapter 3. We used one var stats on grouped data. But it's been a minute. So I'm going to remind you how we did that. I'm totally going to disregard standard deviation for the time being because that just will fall out in our laps when we do this. So back in Chapter 3, you saw relative frequency distributions like this. And I was telling you, if they don't give you the midpoint, you have to calculate the midpoint of each bin or class if they don't give it to you. I gave it to you to keep this a little bit shorter. I don't remember if my lab gives them to you or not. We literally just put these in L1. We're going to put these as decimals in L2, and then we're going to run one var stats. Let's do it. Let me resize my windows so you can see all of this at once. Not that small. Hang on. There we go. So grab your calculator. I'll remind you how we did this. We press the stat button. We press enter because the default option will be to edit your lists. If you still have stuff in your list, like I'll just put some stuff in here. whatever. If you have stuff in your list, remember you have to use the arrows in the upper right corner. Scroll all the way to the top and don't go too far or it loops you back down to the bottom. Scroll to the top so L1 is highlighted. Press clear. Don't press delete. You want L1. Press clear and then enter. All right, let's put these numbers in. 23.5, 34.5, 45.5, 56.5. Need to be extra careful not to have typos right now because that's the classic human mistake. Unfortunately, we humans are really good at typos and they will mess this up. Now, you could actually put these percentages into L2 just the way they are, but I think it'd be good practice for you to practice converting back and forth. So let's turn that 10.2% into 0.102. We'll turn the 67.5 into a 0.675. 18% is 0.18. You have to be very careful with these tiny percentages. This is 0.035, and this is 0.008. So let's put those in. And I'm going to run one-var stats more than once, just in case you're ready now, or if you're not ready now, I'm going to run it again in a moment. So you press stat, you scroll right to calc. One-var stats is automatically selected. If you have a TI-83, the older model like mine, you have to type L1, which is second 1, comma, which is right above the number 7, second 2, which puts L2 there. You have to do this for grouped data. We learned this back in chapter 3 and probably forgot it by now. And then we should get these results. If you have a TI-84, since I can't show you that on my screen, make a note about this. TI-83 versus TI-84. Here we just did one-var stats, L1, comma, L2. In a TI-84, once you hit one-var stats, it's going to ask you some questions. It's going to ask you what your list is. That should be L1. It's going to ask you what your frequency is. You need to make sure that says L2. And then you can calculate. I'm going to run one-var stats again in case I did that before you were ready. So you press stat, scroll right to calc. One-var stats is the very first option, so press enter. And again, if you have a TI-83, you need to type L1, comma, L2 like I do. L1, comma, L2. If you have a TI-84, make sure list says L1 and freq says L2, and then scroll down to calculate. I'm going to snip that into our notes. Did anybody get any different numbers?
I did. I lost you somewhere.
Okay, so were you able to get the one-var stats to run?
Yes.
Okay, you just don't have these numbers. Okay, then what happened, Christiana, is you probably either have a typo in your list, so go back to stat, edit. Do you have these numbers in your list? Do we both have the right numbers?
Yes.
Okay, then the other most common mistake is when you press stat again, scroll right to calc and press enter because the very first option is the one we want. Do you have an older model calculator like mine or do you have a TI-84?
I have the 83.
Okay, so it looks just like mine does right now.
I have 45.5, so apparently I must have put something in, but I have the numbers. I don't know. I'll run it again.
Yeah, that's what I'm trying to get. That's what I'm trying to do with you to make sure that this is straight. So yeah, let's run it again. Press stat, scroll right to calc, because you said your numbers are straight, so that's good. Press enter. Now, before you can finish running this, Christiana, you need to make sure to type L1, which is second one. That's how you get L1 to pop up right there. And then the comma button, which is right above the 7. And then L2, which is second 2. You need to make sure that this is on the screen after the words 1var stats. Are you able to do that?
I have 1var stats, and then it's blinking, but I have N5 as the number that I see. So I don't have what you have on the screen right now.
Okay, tell you what, press clear a couple of times so that your screen goes completely blank.
Okay.
Okay, and let's do it one more time. Stat, go right to calc, press enter. Now do you have the same thing on your screen that I do?
Yes.
Good, all right, press second, 1, comma, which is above the number 7. The comma has its own button. And then second 2 puts the L2 there. Does your screen look like mine now?
Yes.
Awesome. Let's press enter. Do we have the same numbers now?
Yes.
Ah, yeah. So you just didn't have the L1 comma L2 part in there. Yeah, so make sure that you have that L1, L2. This part, y'all, for those of you with the TI-83. Oops, don't do that one, no, come on. Yeah, that's an easy detail to forget to put in because the TI-83 doesn't make it obvious that, hey, you need to tell me something. You have to remember that you have to tell it that. So grouped data is when you have to do that, which is when you have to make the frequency list L2 in a TI-84. If the data is not grouped into bins, then you don't have to do this, which is why sometimes people forget excuse me, which is why sometimes people forget that they do have to do this, because sometimes you do and sometimes you don't. Sometimes it's grouped, sometimes it isn't. So find the expected age. There's a key word. I need you to learn to watch for this one. They're essentially asking you for the mean. We use the symbol mu, even though we only have X bar to work with, and that's fine. I told you back in chapter 3 that they're interchangeable when the context is not specified. So 36.392 years. I think I made these numbers up, if I remember right, but it kind of makes sense. I would expect a lumberjack to be around 36 years old. The standard deviation is sigma, which has this not very pretty formula that we never use. Just like I told you in chapter 3, we don't use it. That's an archaic practice. We live in the 21st century. We have sigma right here. We're going to need to round that number. So that will be 7.5-ish or whatever my lab tells you to round to. We don't use the standard deviation very much in this chapter. What does it tell you in real life? It tells you how much variation or how spread out you expect the ages of lumberjacks to be. So we expect a lumberjack to be 36 years old, but I also wouldn't be shocked if the lumberjack was, say, 43, because that's within a standard deviation. And according to the empirical rule that we learned way back, I think that was also chapter 3, being within one standard deviation of the mean puts you at 68% of your whole distribution. 68% is the majority. So it's not surprising if a lumberjack is 36, but it's also not surprising if a lumberjack is 43. But we're primarily going to focus on the expected value. Standard deviation is something that we don't need extensively until chapter 7. What do you think? Are all the details of this example clear? We went through that one nice and slowly.